take a look at some equations that have rational expressions in them. For instance, this particular one here. Notice that the denominators of 5m and 4 would have a common denominator of 20m. If we multiply everything by 20m, we'll have a much nicer equation to solve. So let's multiply and distribute 20m times m over 5 plus 20m times 5 over m equals 20m times m plus 3 over 4. Here, notice 5 goes into 24 times. So 4 times m would leave you with a 4m squared. Notice we no longer have a rational expression there. Here, the m's cancel. 20 times 5 is 100. And that's going to equal, over here, 4 will go into the 25 times. So we're actually distributing a 5m times this. 5m times m is 5m squared. 5m times 3 is a 15m. Now we need to move everything to one side so that we have 0 on one side and we can factor. So how about if we subtract 4m from both sides? Subtracting it here would make that go away. Subtracting it here would give us an m squared. And then we also need to move our 100. Since it's a positive 100, we'll subtract 100. So we won't be able to combine that here, but we'll have a 15m minus 100. That takes this 4m squared, subtracts it from here to get a 1m squared, subtracts 100 from both sides so that we have a 15m minus 100 after our m squared. We only have 0 left on this side. We can now factor this and find our solutions. So factors of negative 100 that would add up to a positive 15 give us a positive 20 and a negative 5. This multiplied would give us 20m. This would give us a negative 5m. When you add those together, you get 15m. And 20 times negative 5 would be the negative 100, and m times m would be the m squared. We now can use our 0 principle, where we have m plus 20 equaling 0 for one possible solution, and m minus 5 equaling 0 for the other solution. This or this would work perfectly fine in our equation. So we'll go ahead and subtract 20 from both sides here. One possible answer would be negative 20, and add 5 here, so that would give us the other possible answer of 5. So we could have m equal negative 20, or m could equal 5. Now we have to check for extraneous solutions in these problems. So we have to look at the original equation here and see if either of those answers would make a 0 in the denominator of any of these original rational expressions. And neither of them would, so negative 20 or 5 would work just fine. So our solution set is negative 20 or 5.